All right, welcome. Today, we're going to get into the science of color that's, well, basically built to last forever. We're talking about a process that gives some of our toughest fabrics their amazing, indestructible colors. It's called vat dyeing.
So, have you ever really thought about why your favorite pair of blue jeans fades over the years into that perfect worn-in look, but then the color on a set of hotel towels or a mechanic's uniform just seems to last forever, no matter how many times you wash it? It's a great question, and the answer isn't just about quality. It's all about some really clever chemistry.
And that secret is a method called vat dyeing. For any fabric that absolutely has to put up with tough conditions, we're talking intense sun, harsh industrial washing, even bleach, this process is seen as the absolute gold standard. It's how you create permanent, super durable color.
So what is it about this process that creates such an incredibly indestructible color? Let's dig in and see why these dyes are just so uniquely strong.
The proof is really in the performance. Look at this. Vat dyes have the highest possible resistance ratings pretty much across the board. They have top-tier wash fastness, which means they don't bleed or fade. They have unbeatable light fastness, so the sun doesn't bleach them out. And they've got this incredible chlorine fastness, which is exactly why they're perfect for stuff like hotel towels. It's really no surprise they're the go-to for heavy-duty things like workwear, uniforms, and of course classic denim.
So let's get to the core of how this all works. The entire idea behind vat dyeing isn't about brute force. It's actually based on this incredibly clever chemical trick that allows the dye to literally become part of the fabric itself.
Okay, to really get your head around this, let's use an analogy. Let's call it the liquid key. Imagine you've got a big solid key, that's our dye pigment, and you have a fabric fiber with all these tiny little microscopic pores. That's the keyhole. Now, the solid key is way too big to fit, but what if you could, just for a moment, melt that key into a liquid? Then it could flow right into the keyhole, right? And then, once it's inside, what if you could make it turn solid again, back into its original big shape? Well, it would be permanently locked inside. That, in a nutshell, is exactly what vat dyeing does.
Now, this whole melting and resolidifying thing isn't magic. It's a perfectly controlled two-part chemical reaction. The two big words you need to know are reduction and oxidation. They're basically two sides of the same coin, and they work in perfect opposition to get the job done.
And here you can see that chemical switch in action. On the left, we've got reduction. Its only job is to take that big, insoluble dye pigment, our solid key, and make it so it can dissolve in water. It becomes soluble. That's what lets it get absorbed into the fabric. Then, over on the right, you've got oxidation, and its job is to do the complete opposite. It takes that soluble dye that's now deep inside the fiber and flips it back to its original insoluble form. Boom! It's locked in for good.
This temporary soluble state of the dye has a special name. It's called the leukovat, and this is where a little bit of visual magic happens. See, the leukovat form is often a completely different color from the final shade. So for example, a deep indigo blue dye might actually look like a pale yellowy green when it's in its soluble leuco state. It's a true transformation.
Okay, so we get the clever chemical trick at the heart of it all. But how does this actually play out in a real factory? Well, it all comes down to a really precise four-stage process that takes the dye from a chemical mixture and gets it locked into the fabric. So here's the roadmap. First up is vatting. That's where we prepare the chemical reaction. Second is dyeing, when the fabric soaks up the color. Third is oxidation, where the color gets locked in place. And finally, there's a super important finishing step called soaping. Let's break each of those down real quick. Stage 1, vatting, is all about mixing the recipe. You take your insoluble dye pigment, you add a reducing agent, usually something called sodium hydrosulfite, or just hydro for short, and then you add a strong alkali, like sodium hydroxide, which you might know as caustic soda. These ingredients all work together to change the dye into that soluble leukovat form we just talked about.
Once that dye bath is ready, it's time for stage 2, dyeing. The fabric gets submerged, and because the dye is now soluble, it can travel deep into the structure of the cotton fibers. Sometimes, other things like salt are added here to help push even more of the dye out of the water and onto the fabric. And now for the big reveal, oxidation. As the fabric is pulled out of the dye bath and hits the air, it's exposed to oxygen, and that reverse reaction just kicks right in. The leukovat dye switches back to its original insoluble pigment form. This is the moment right here where the dye becomes physically trapped and the true, permanent color just blossoms right before your eyes. It's pretty cool to watch. Now, you might think we're all done, but this last stage, soaping, is absolutely critical. It's basically a hot wash with a special detergent, and it does 3 really important things. First, it gets rid of any loose dye just sitting on the surface, which is what stops the color from rubbing off on things. Second, it actually helps the dye molecules inside the fiber form into perfect crystals, which maximizes the color's fastness and final shade. And third, it just washes away all the leftover chemicals, so you get a better, softer fabric in the end.
So, as you can probably guess, with all these chemicals in different stages, this is not a one-size-fits-all kind of deal. Vat dyeing is a process that requires some incredible precision and control.
And this table here shows you just how precise we're talking. This is a classification system that dyers use because different dyes need very different conditions to work properly. Just look at the cold dyes. They need low temperatures but a whole lot of salt. Now compare that to the normal dyes down at the bottom. They need high heat but with little or no salt at all. Getting these variables wrong, even by a little bit, can totally ruin a whole batch of fabric. We're talking uneven color, poor fastness, precision is everything here.
So we've clearly established that vat dyeing is incredibly effective. It's the best of the best. But is it always the right choice? Let's take a second to weigh the really big benefits against some of the pretty notable drawbacks. At the end of the day, it's a trade-off. On one hand, you have everything we've been talking about, just unmatched fastness, extreme durability, and these beautiful, rich, deep colors. But on the other hand, there's the reality of it. It's a complex and expensive process. The range of really bright, vibrant colors is kind of limited compared to other dye types. And, the chemicals involved mean you have to have really careful wastewater treatment to manage the environmental impact.
Ultimately, this quote really nails the whole reason this process is so amazing. It's not a chemical bond holding it in place, it's a physical entrapment. The dye molecule is literally rebuilt inside the fiber, like a prisoner that just can't escape. That right there is the simple, elegant reason for its incredible performance.
And that really leaves us with a final thought, doesn't it? Vat dyeing is all about an investment in something that lasts, in durability. It creates products that are designed to endure. So, in a world that's more and more about fast fashion, it makes you wonder, is the future of color going to be something that's built to last through complex chemistry, or is it something that's just designed to fade away? Something to think about. Thanks for tuning in.